Welcome to the video, and this is our third review session for AP Stats Final Review, and thank you so much for following along. In this video, we're going to mainly focus on Unit 3's content and mostly experimental design. So starting with some basic vocabulary. Population means the entire group of interest. Sample means subset of the population that we're examining. Parameter means number from the population, and those are some common symbols we're going to see: mu, p, beta, and data. So be sure to familiarize with those. Statistic means number from sample. Those are also the symbols that correlates with parameter, and you can see that they correspond to each other. Census means survey the entire population. And sampling, here are also some vocabularies. I know Unit 3 will have a lot of vocabularies to know, but just stick with me. Sample design and voluntary response and convenience sampling. So just a quick review of those two. A voluntary response is if, for example, you put a questionnaire to a group of people and not everyone will be volunteer to respond, right? Like some people respond to it and some don't. And when you're collecting data in that way, you have to really be careful, because the reason that not everyone is willing to respond may affect the results of your data, right? Like, what are the reasons behind those people that are not willing to respond? For convenience sampling is, for example, I just stand at the door of the classroom before the bell ring, and I just taking the response for the last 5 people who came in, or last 10 people, I mean. And that will also be a convenience sampling, because you're only examining that small group of people in that specific time period, in that specific condition. So your data will very likely be biased. And what is sampling? What is simple random sampling, also known as SRS? This is the every sample of size n has the same chance. So remember that this is the formal definition for SRS. It's not like every people in the population has every chance to get in or caught on. It's the every sample of sample size has the same chance. So sample is a key term. Stratified sampling is subgroups that are different or include all in sample. So for example, if I want to take an examination for all of the students in my high school, I will take 50 students from freshman, sophomore, junior, and senior, like all the way up to the last grade that I'm calling, and I will take every students from, like, I randomly select students from each grade, and I will put them together to do my experiment. And that's how a stratified sampling looks like. And be careful not to confuse it with cluster sampling. Cluster sampling is randomly sample some subgroups to include. It also has it will has a multi-stage. And what differentiate that from stratified sampling is stratified sampling, every subgroup is different. We clearly know that they're different. But for cluster sampling, we assume that each subgroup don't have that much different to each other. So it doesn't matter like which group I'm taking on, because all of them are similar to each other. So I can just take 1 or 2 groups to do the experiment for the whole population. Systematic sampling is randomly pick starting point and going every nth person. So also taking the example as like standing in the door of the classroom before the bell rings, and I will take examination for every 5th person I met walking the classroom, and that will be a systematic sampling. And what are some bias? Bias, we have response bias, non-response bias, voluntary response bias, and undercoverage bias. What is a response bias? It's experiment as influencing response. So response bias, so for example, if I threw out a question, but my phrasing of that question is pretty weird, or it's lean to one response, so therefore the answer I got will definitely be biased, because my phrasing of my question will impact the response that I got. Non-response bias is individual chosen but chooses not to participate. And that will be similar to the voluntary response, but remember that they're different responses, different bias, and non-response bias is also like I throw out a questionnaire to a group of people, but some people are not willing to respond, and I will be asking myself, well, what are the reasons behind those non-respond people that will be related to our conclusion. A voluntary response bias is volunteer to be part of the sample. So a good example for that is if you open any of the website trying to find the rating of one product or one, I don't know, professor or something, and you will see that sometimes the response are pretty skewed. It's not a bimodal graph if you're graphing onto a curve, and most likely it will be a bimodal graph, which it has a lot of people who are rating like 1 star for that, and a lot of people who are rating 5 star for that. We're assuming that 5 star is the maximum star. So what are the people that like just in the middle? Like you won't see a lot of that ratings in that situation, because most of the people who are willing to put their answers in is they have strong opinion of that product or person. But what are the people that are not having a strong opinion to that thing, maybe not willing to put their response onto it. So therefore, the data we collect is also not the true picture. And remember, that's involuntary response bias. And undercoverage bias is some group not selected. So basically, when we're doing our sample, some samples does not include it, but we still want to examining the whole population, but there's several samples that were not included in the population, so therefore definitely it will draw bias to our conclusion. Okay, and moving on to experiments. Experiments means impose a treatment randomly. So here are some key terms. Experiment, experimental units, that's the subject that we're examining. So for example, if I want to know how many teachers that blah blah blah, then the teacher will be my experimental unit. A treatment is randomly imposed. And control group, confounded variables, and lurking variables. So those two variables, make sure do not confuse with them. Confounded variable means caused by setup of experiment. Lurking variable is observations or pre-existing variables. So from the meaning, you will see the difference. The confounded variable is when you're doing the experimental setup, what are some, like sometimes you will not pay attention or you will overlook some details that will maybe a factor to our conclusion. Therefore, that factor become a confounded variable. A lurking variable, on the other hand, is the pre-existing variables, which means even though you still pay attention to the little details when you're doing the experiment, you still have lurking variables exist. That factor you cannot change or manipulate, and that will be a lurking variable. Components of an experiment will be those four: randomization, replication, and control, also comparison. Randomization, just as I repeat again and again, that just means you randomly assign samples or randomly pick groups, experimental units. Replication is you do the trial more than one time. And that's pretty important because we cannot guarantee that we do it once, then like there's no lurking variables or confounded variables. And therefore, in order to reduce those, we're gonna repeat our sampling. For control group, it's not always required, but it's not a bad idea to put a control group on your experiments. A comparison, definitely you want to compare the results of the bivariate data, and that's the reason that we're doing a bivariate experiment, right? And some other things, blind versus double blind, block design means control stratified sample. Like you have to control some variables, and it's most likely will be a stratified sample. You run an experiment on each block. So basically we just same purpose. We want to reduce confounded variables or lurking variables or other factors may result or may impact our conclusion as much as we can. For a matched pairs design, it will be block of 2. So we either put our treatments into one subject or we put our treatments into twins. So basically we want to make sure that like all of the other factors are stayed the same except the variables that we're examining. The observational studies are no treatments and we're only observing natural behavior. So no treatments and no experiment, and we're just basically observing the patterns by our eyes, and we draw the conclusion. And remember that we can never draw a cause and effect conclusion from observational studies. How to run a simulation will be those steps. First, identify the component to be repeated. Second, explain how you will model outcome or assign digits. Third will be explain how you will simulate trial. Fourth will be state clearly what the response variable is. Fifth, run several trials. Sixth, analyze the response variable. Seventh, state your conclusion in context of the problem. So the terms that are underlined in green are the key things that you're going to pay attention to. And remember, I have the video for simulation in my unit, I believe it's 3 or 4, I think. I think this is a review, like basically for unit 3, but this simulation, sometimes the curriculum will put it in unit 3, sometimes it will go back to unit 4. So it really depends. But I have this video either in my unit 3 or unit 4 playlist. So if you want to take a deeper review on it, feel free to check that out. And talking about that, that's all for this video, and I hope you learned something from it. That's just a quick review of unit 3. I'm trying to touch all of the details or key terms, but definitely there's some parts that I'm not like teaching you right now. So feel free to check all of my playlist, and thank you so much for watching.